So we're gonna go through how to do best fits on the calculator. And I made up this problem about sunflowers. So you have this row of numbers, which are like the inputs, those are weeks. And then you have this row of numbers, which is the heights. And then you're asked to try to model this either with a linear or an exponential or something called a logistic, which maybe you've never heard of. And then you're asked to maybe make some predictions and use the model and decide which one you think is best. Okay, so you are going to go to your calculator, and one of the things that goes wrong is sometimes this L1 and L2 are missing. So you don't have to do this every time, but if your L1 and L2 are missing, or something seems really wrong, go to Stat, and you see how it says Setup Editor? This is a good way to fix problems. So maybe you run it once and you never run it again, but I would do that. It's not going to do anything, but do Setup Editor, and then, like I said, it'll just say Done. And then I want you to go back into Stat, hit Edit. I already have mine in there from the previous class, but you're going to enter these numbers. Before you enter these numbers, let me just say a couple things, okay? If you go on top of L1 and you hit delete, it'll delete the whole column, it'll delete L1, and then you'll be in trouble. You don't want to make it all disappear. If you hit clear on L1, it'll clear all the numbers. So clear is safe, delete is bad. On the numbers themselves, you could hit delete. So if I wanted to delete this 10, I could hit delete, okay? But you don't want to hit delete on L1 or L2. Clear is fine, delete is bad. Go on and enter these numbers in. Make sure you get all of them in there, and I'll give you some time to do that. And I will have a running list of commands. So far we did Stat Setup Editor, Stat Edit. Make sure you're copying off the notes list and not just looking at my screen. Sometimes people get errors and they don't know why. And one of the typical reasons that people get an error is that they don't have these matching up at the end. If you have something like this, where these don't match up, you'll get an error for sure, because it won't be able to plot this point. There might be problems where it says like predict week 11, and people will put 11 in here, and then they won't have this matching up. Like on the Halley's Comet problem, people might put in like this, I'm looking for the 7th one, and they know they're looking for this one. These have to match up. You cannot have these not matching up. So before you, how come this is not deleting? Let's try this again. Delete, come on. There you go. These have to match up, okay? All right, now, when you want to plot them, you want to go to y equals and turn the plot on. Now you have to remember to turn that plot off eventually. When people tell me they have a calculator problem, the first thing I do is I go to y equals and see if they have a plot on. Because a lot of times people are trying to do things and they leave that plot on, and it causes problems. So make sure we turned it on. When you do something else in your calculator, you gotta turn it off. Okay, so plot 1 is on. Now you only have to do this once to check it, but if you go second stat plot, it'll show you that plot 1 is on, and if you go into this menu, it'll show you the type. You want to make sure it's this type. L1, L2 are the ones you want. The mark doesn't make any difference. The color doesn't make any difference. Okay, that was under second y equals, which is stat plot. Again, you don't have to do this because this is the default. Unless you mess with this, it's going to be like that. Okay, so you went y equals, you hit plot 1. Then you're going to go to zoom and then zoom stat. So do zoom and zoom stat. Turning the plot on plots the points, and then doing zoom stat finds the points. If you do zoom stat and then you turn your plot on, it's not going to work. You got to turn the plot on, and that plots the points. Then you got to find them with zoom stat. And in yours, if yours don't look like mine, you got a problem. Everybody's doing okay so far? Okay. I can stop and walk over and help you. And like I said, you could get help from somebody. If you have one number way off this, then something's wrong. If it didn't graph, it's because either you didn't turn the plot on or you didn't have your columns where they end up with the same number. Okay, so you do that. Now that shows you your data. Then you have to do the best fits, okay? So you're gonna hit stat, but this time you're gonna go to calculate. I have a list here that I'm writing. I'll try to move it over so you can see it. So you'll be able to see this list as we go, but we did y equals plot, zoom, zoom stat. Now you go to stat calculate, and now you're gonna look through these and you're gonna pick the one that you think is best, okay? There's some on here that you're never gonna use. I'll write a list for you, but I'll just go through them really quickly. 1 and 2 you're never gonna use for me. 3, I don't even know what that is. 4 is lines, that's what we're gonna do next. 8 is also lines. So I don't know why there's 2 different versions of lines, but there's never a reason to use number 8. 5 is quadratic, you might use that. 6 is cubic. 7 is quartic. We're never going to use those, so just never choose those. Sometimes 9 people think is lines too. They're like, oh, ln, that's lines, but that's natural log. The 0, 1 is exponential. We'll use that. A is power regression. We're not going to use powers, so you don't have to worry about that one. B is logistic. We'll use that today. And then C is sine regression, which is like a wave. So we're going to use 4 right now. So you're going to hit 4. Now, some of you might not see this screen. If you don't see this screen, I'm going to tell you what to do. If you do see this screen, just do what I'm doing. So you choose the one you want. Now, if you don't see this screen, you don't have to arrow. You just don't do anything yet. But for those of you who do have this screen, arrow over to where it says store regression equation. Frequency list, just leave off. That's not something that we have to do. And then everybody, whether you see this screen or not, is going to hit the following keys. We're trying to find y1. You hit vars, which is variables, yvars, which is y variables, function y1. Okay, I'll write that down. It's variables, vars. It's right above the tangent button. Arrow over to yvars, function y1. Now, the people who don't have this screen are going to hit those same buttons. Vars, yvars, function y1. It won't look like this, but it'll do the same thing. Then you would calculate. The people who don't have that screen, just hit enter. I'll come over and help you if you didn't get that screen. And this pops up, okay? Now, don't write anything down on your notes just yet. When you hit y equals, you see how it's in y1 now? The problem with these are sometimes is that they're really long equations, and then they have really long decimals, 10 digits. And, you know, it's not that you can't round this or that you can't see it. It's just that it doesn't, you can't see the whole thing easily. So I'm going to have you round these, and I am going to mark you wrong if you don't round correctly. You have to round correctly. And I'm going to show you how to round on the calculator, which should make it really easy. Okay, so this I'm not going to write down. I'm just going to explain it to you. And if you don't want to do it and you want to round in your brain, go for it. But if you want to learn how to make the calculator round, I will explain that to you now. So float is the default one. If you change this, make sure you change it back. when you go to change it back, don't put it on 0. Some people think 0 is the default. But if you have it on 0 and you go to do like 7 divided by 2, it's going to round to the nearest whole number. And you're going to have a lot of wrong answers if you do that. If you want to round to 2 decimal places, which, a lot of times I ask, just know that it's going to round everything to 2 decimal places. So you'll see like 7.00. If you were to go to your list, everything's now going to be 2 decimal places. We want to be 4 decimal places. So go into mode and change it to 4. And then you don't have to hit enter or anything. You just quit. And this will still be the same. So I'm just going to run this again. Calculate, linear regression, store regression, vars, y vars, function y1, calculate. And now it's going to be 4 decimal places. And you can write that down on that line. If you're not getting this exact equation, either you are typing something in wrong or you plugged your data in wrong, because everybody should be identical to mine. Anybody having a problem that I can help with? So you're going here, and then, so you don't hit enter. You go vars, y vars, function y1, and then hit enter. And then it will be in there. And then you gotta do the run. Yeah, no problem. So if you put on this 4, you'll round everything to 4 decimal places. And that's just recommended so that it's easier to see, and then so you just leave it like that as long as we're rounding, and this way it's just easier to see. Okay, everybody happy? So you go mode, and then it's on 4. I think you should have to do this again. Yeah, you gotta do it again. So you gotta rerun it. Okay, so we'll leave it on the 4. We're leaving it on the 4, but you need to know when you walk out of here that you got to change 2 things in your calculator. You got to take the plot and turn it off later, and you got to make it go back to float. You got that? Okay. So now we're going to write that down. You wrote it down in here? Make sure you write the y equals. Okay, it drives me nuts when people are writing an equation and they don't put the equal sign or the y. So please try to remember to put y equals. It says to round to 4 decimal places. This is our equation. This is our model. And we could judge for ourselves whether we think it's a good model or not. All right, what's your opinion? Good, bad, okay? What do you think? No one has an opinion. Okay, well, maybe you think it's good, maybe you think it's bad. Let's try exponential, and we'll see what your opinion about that one is. So I go to stat, I do edit. No, I don't, sorry. I do stat, I do calculate, and this time I select exponential. And I want to store this in y2. So I went stat, calculate. Now I'm going to go vars, y vars, function. If I pick y1, it will delete my y1 and put this in. And sometimes that's what you want to do. Sometimes you want to get rid of the y1. But I want to put in y2 so that you can compare them. So I did store regression y2. It's got it in there in 4 decimal places. I look at my graph. The red one is the new one. Do you think that's better or worse? Worse, okay. Yeah. I know it was you have to think about that one, but it's really terrible. So it's worse, okay? All right, it's okay to have an opinion about these things. So the blue one is okay, the red one is worse. And that's the exponential one. Now we still have to write that down. So if you go to y equals, I'm gonna write this down but I'm going to use parentheses, okay? So you could wait for me to write it, or you could just go for it, but I'm using parentheses the typical way we write exponentials, not with the multiplication symbol. So if you use the multiplication symbol, I won't mark it wrong, but this is the typical way we write exponential. We don't think that's a good model, but it does ask us to write it down, so we wrote it down. And then the third one we're going to do is something called logistic. So we do it all over again. So this is good practice, okay? So we're doing it 3 times in class. You'll do it more than once on the homework. So I go stat, calculate, and this time I find logistic. And you might say, I don't know what logistic is. Well, don't worry. We'll talk about logistic more than once this chapter. And I will give you a brief explanation what it is in just a second. And we're going to store this in Y3. Vars, y vars, function, y3. It's going to look ugly, you know, like this. Like if you try to write this out, it's going to look kind of crazy. When you go to y equals, it's not exactly clear what that is. I will write it down for you how I would write it on my paper. And the logistic ones are all written kind of the same way. So the very first one you're seeing. So I would just not write anything for 1 second. And then once I write it out, I will show you what I wrote. This one doesn't all fit. That E has a negative number always on these logistics. And they always have that X, and sometimes people forget to write the X. So let me show you my screen here. So you should write it as one big fraction and just write down what I wrote down. Did anybody look at the graph yet? Do you have an opinion about this one, or this better? Okay. I gave people a chance to copy this down. The logistic one is the best. And sometimes the linear is the best. Sometimes the exponential is the best. Sometimes quadratic is the best. Like I said, I'll make you a list of kind of like what to choose from and when to pick what. But like you wouldn't pick quadratic on this problem because it's not one of the ones they asked you. They didn't say, you know, try quadratic and try sine and try natural log. So only do the ones they suggest, and then you're picking from those. So logistic is the best. And let's hit graph on the calculator so we can see it. Look at that, it's beautiful. Okay, so that one fits it. You know, it doesn't necessarily have to hit every point. It doesn't even have to hit any of the points, but it fits the shape of that, you know, almost perfectly. If you want to make these disappear, but you don't want to lose them completely, you can click on the equal signs. The equal signs will make the graphs go away but leave the information. So that's maybe a way to do that so that you don't lose the information. So now I just see the logistic only. Everybody good with that? Okay. So I went to y equals, and I just clicked on the equal sign. So you arrow over to the equal sign, that's on and that's off. I know a lot about these calculators. I know more than anybody in their life would want to know about these calculators. Okay? If they ever switch to a different kind of calculator, I'm just going to quit. Because thank God they've been using the same calculators ever since I was in school. Okay. I was going to say something. Oh, I just want to describe to you what logistic is. So you learned I'm sure, in a lot of detail about exponential growth. Like populations grow exponentially, whether it's like a population of bacteria or a population of people. Some things grow linearly. Maybe plants grow linearly, but I think you could agree that plants don't grow linearly where they go up and up and up and up and they never stop. Okay? And same thing with populations of animals. So maybe you have a bunch of rabbits in the forest, right? And these rabbits are in the forest and they're running around, they're eating, and they're having a good time, and they're having babies. Okay, we're not going to get into too much detail about them making babies. They're not having babies. Okay, and there's more and more rabbits in the forest, and they're running around eating, having a good time. But there's only so much food in the forest. Maybe some wolves hear about the forest, like, hey, there's a forest, bunch of rabbits in there. Let's go and eat some rabbits. And some of the rabbits are not making it. Okay, it's sad, but this is gonna level off. Maybe there's not enough food. Maybe they're getting murdered by wolves. Different reasons. Okay, because there's a reason why there's not 10 billion rabbits on the planet. Is because something is making it level off. And, some plants grow in this way too. They grow really fast and then they kind of slow down and level off, right? They don't just keep getting bigger and bigger and bigger forever. Okay, I'm sorry if that rabbit story upset anybody. But these have not only a floor, but they have like a ceiling. So exponentials have a horizontal asymptote, but no top one. These have a horizontal asymptote on the top and on the bottom. So it's like a ceiling. You don't need to know this, but this number up here, that's the horizontal asymptote of this line. The numbers never get bigger than that. Now, our model might not be the best model for sunflowers, but according to this data, it looks like this. And according to this data, if this model is correct, and that's an if this is correct, then that sunflower will never get bigger than that number. You following all this? Okay, so it's a little bit about logistic. Logistic makes that S shape. Let's make a list at the top of the paper. Okay, lin, reg, and there's two of them. That's lines. And I shouldn't have to explain to people what lines are. Lines are straight. Exponential regression you might use. And that could be exponential growth or exponential decay. Quadratic regression you might use. I know they didn't ask you on this one. And don't use quadratic unless it is a U shape, an upside down U, or a normal U. If it doesn't make a U shape, it doesn't make a turn, don't do that. If it's half of a parabola and you're like, oh, it's half a parabola, and I try to do a parabola and it looks good. If it's half a parabola, exponential is probably better, okay? So only use quadratic when you have a U. Now, there might be some instances in real life, like dropping a ball where you only have half of a U, and quadratic is better. But I'm telling you to eliminate any ambiguity about like which one to pick. For me, if it's half of a U, do exponential. If it's a U where you could see it makes a turn, then use quadratic. Because sometimes it's hard to tell like which one's better if you don't follow that rule. Then there's logistic, which doesn't stand for anything besides logistics, so I don't have to draw an arrow here. But those literally make the same shape every time, like an S. Okay, they have a floor and a ceiling. I think one said synreg, which is sine, don't say sin. And that's when you have a wave. And we haven't learned much about waves in this class, obviously. Cosine and sine graphs have the same shape. It's just where they start is different. So there's no cosine regression because whatever you could do with cosine, you could do with sine. So there's no need to have a cosine regression. function, and it doesn't have one. So natural log, power, those ones you're never going to do for me. If it says to do cubic, you could do cubic, but I'm not going to list that one. So these are really the ones you're picking from. Any question about this? Okay, so now it says use the model you feel better to predict the height of the sunflower to 15 weeks. What I don't want you to do is look at 15 and estimate. Be like, 15 seems like 300, That's not using the model. When they say use the model, sometimes they use the equation. I think on the quiz I wrote use the equation, so it's very specific. When it says use the equation, it means use the equation. Now there's two ways to do this. I want to do the height after 15 weeks. One way to do this is to take 15 and to plug it into this. I don't want you to do it that way. Plugging 15 into this, first of all, these are rounded, so that is not ideal. And the other reason is that it might be a little bit tricky to plug some things in, and the calculator will do it for you in a much faster way. So I want to use second calculate value. Second calculate value is plugging in x values. Now I'm going to get an error here. I'm going to go to second calculate value. I'm going to type in x equals 15. Guaranteed it's going to get an error here, and you need to know why. Does anybody know why I'm getting an error? I'm going to take a guess. I'm typing 15 in. It's saying it's wrong. Anybody want to guess? Go ahead. It's not because there's three, because let me show you. That's a good guess, though. If I type in 5, I will get a value. And there are 3 lines, so you have to be aware of that for sure. Now, I know some of you took the first 2 off, but let's say you have 3 lines. You should know that if you want to switch lines, you hit up and down. So hitting up and down will switch lines. So if I wanted to know 5, that's 5. And I don't even have to even hit it again. I can just hit 9. If I want to know 9, there's 9. And then again, I can hit up and down. Go ahead.
Because 15 is off the window?
Yeah, because 15 is off the window. Now, I don't know if you noticed this, but I hit 9, and 9 was 315. That's off the window. It can do y's off the window. It can't do x's off the window. So if the y is off the window, not a big deal. If the x off the window, it can't do it. If you're trying to do 15, this has to be 15 or higher. I wouldn't put in 15. I'd go past 15. So I'm going to do 20. And then I'm going to hit graph. And then I'm going to go second calculate value 15. And what do you think about this answer? 415.91. You like that answer? That's the wrong equation, right? That's the line. So I could just arrow up and down until I get onto that logistic. Or I could turn those other 2 off or delete them. And I could do this. But just be aware of this. Once you make your decision, it might not be a bad idea to delete it. We also said that number is going to be less than this. It's not something you need to know, but it's something that we said, and so it should be true. And that's in centimeters. And it says 2 decimal places this time, so make sure you do 2 decimal places. Go ahead and read the next question so you know what that is asking us to do. So this one, you don't just type in 100 the same way we did 15. This is centimeters, and it's asking us for a week, so this is the reverse. Now in this case, if I were to plug this 100 into y and try to solve this, I could do it, but I'd have to do cross multiplying. I'd have to use logarithms. It would be a big pain. And these are rounded values. So ideally, I wouldn't do that. There's a better way to do this. There is no second calculate y value. There's only second calculate x value. 0 is when it hits the x-axis. That's not what we want. So let's first turn these off so I can stop looking at these 2. Does anybody know how I'm going to figure out, using the graphing calculator, using the graph, when the y is 100? For what x is the y 100? Todd, go ahead.
You put in an equation and the y equals for y equals 100.
Yeah. Now, this is the way I would do it, and should be the way you were taught. You make a horizontal line at 100. Okay. So I just typed in 100, hit graph, and then what do I do, Ta?
You go to second calc, and then press 5 for intersect.
Yeah. So I want to find out where they intersect. Now, you could have some problems where maybe you have like a parabola and a line, or cubic and a line, it hits more than once. Now, these only hit once, but sometimes they hit more than once. Remember, up and down changes equations. So let's say you had all your equations on there. You got to make sure you're on the logistic. It automatically switches to the next line. So if you only have 2 on there, then you just hit enter, enter. But if you have 3 or 4 on there, then you got to arrow and make sure you have the right one. These only hit once, so your guess could be terrible because the calculator knows what you're trying to do. So if your guess is bad, it figures it out. But if you have a graph that is like a wave that goes up and down, up and down, up and down, and there's a horizontal line that goes through it, it's going to pick the one that this cursor is closest to. So it only hits once, so our guess doesn't really matter, but just know that guess does have a purpose. Because if it hits twice, it wants to know which one do you mean. Write down the line what you would write. Any questions about anything that we did so far? Okay. So I'm more picky about the rounding than I am with the labeling. It's really nice if you can label things correctly. You have to read the problems and make sure that you did these. And I'll say this over and over again. When you're checking your work on a quiz, I don't mean do every single step over again. You could do that if you want. But sometimes just reading the problem, the first time you read it, you might not notice that it says 2 decimal places. Then you finish the whole quiz, and when you read it the second time, you see 2 decimal places there. You say, oh, did I do 2 decimal places or not? So this one's 2 decimal places, and this one should be weeks. The reason I didn't have you do a future one, a lot of these, they say like, when will the plant reach a certain height? The reason I didn't have you do a future one is because on a line, you could do future ones, but on these logistic, it levels out really fast here. So like all of these values are based almost the same height. So I didn't ask you, when does it hit 400 centimeters? Because it never hits 400 centimeters. Our line would hit 400 centimeters, but this one doesn't really go. So I didn't ask a future one. I asked a, intermediate one. But if it was a future one, you would do the same thing. And remember what I said, that it can find y's off the graph, it just can't do x's off the graph. Now, I still would make sure my y is on the graph so I could see my horizontal line. Okay, so that is it for the note.